Assalamu alaikum students. Today we will start chapter 15, that is stoichiometry. In this chapter we will study molar volume concept, concentration and its different units, stoichiometry calculations and different numericals that involve the volume and concentration of solutions using titration method, empirical formula, molecular formula calculation, percentage yield, percentage composition, mass and percentage purity from the given data. Let's start our first topic of this chapter, which is molar volume. Volume of gas varies with change in pressure. Previously we have studied different laws, and from these laws one of the law was the Boyle's law. So according to Boyle's law, volume is inversely proportional to the pressure. So if pressure is high, volume will be less. And volume also varies with the temperature, and this law is called Charles' law, in which we have studied previously that volume is directly proportional to the temperature. If temperature is high, volume will be greater, and if temperature is low, volume will be less. So in order to compare the volume occupied by different gases, we must adopt a set of standard conditions of temperature and pressure. These standard conditions are called room temperature and pressure, which is represented by RTP. So room temperature is 25 degrees Celsius and room pressure is 1 atmospheric pressure. 25 degrees Celsius, that is equal to 298 Kelvin, and 1 atmosphere, which is equal to 760 torr. These are used as standard conditions of temperature and pressure for the measurement of volumes of gases at room temperature. So it has been found that 1 mole of all gases occupies volume of 24 dm cube at room temperature. This is called molar volume. So this sentence is very important. It is a definition of molar volume. It's worth noting that 1 mole of each gas contains the same number of molecules, occupies the same volume at the same time, has different mass. So, irrespective of the type of gas, volume occupied will be same if different gases have the same number of moles. In other words, masses and the size of molecules of gases do not change the volume occupied by them. So these two factors, that is mass and size of the gas molecule, does not affect the volume which is occupied by the gas. The concept of molar volume is useful because it enables us to calculate the number of moles and mass of the gas if we know their volume. First example of this chapter is to calculate the number of moles of nitrogen gas that are present when it occupies volume of 25.2.5 dm cube at room temperature and pressure. So in this numerical, the given data is volume of nitrogen gas, which is 2.5 dm cube, and conditions are room temperature and pressure. That means it will occupy volume of 24 dm cube, which is molar volume, and we have to find the number of moles of nitrogen gas. So its solution is given. 24 dm cube, which is molar volume, is occupied by how many moles, and we already know that it is 1 mole. So 1 dm cube will be occupied by how many moles of nitrogen? It is equal to 1 over 24 moles. 2.5 dm cube, which is a given volume, will be occupied by how many moles of nitrogen? And answer here will be 1 over 24 multiplied by 2.5. After calculations, answer will be 0.10 moles. This problem can be solved by simply using the formula which is given here. Number of moles of gas is equal to volume of gas at room temperature and pressure and divided by molar volume of the gas. Example 2. Calculate the volume of 0.5 moles of hydrogen at room temperature and pressure. In this numerical, given data is the volume, given data is the number of moles of hydrogen at room temperature and pressure, and we have to find the volume. So we will simply use the formula which was given at the top of this example. So number of moles, that are 0.5, that is equal to volume of hydrogen divided by 24. 24 here is the molar volume. By simplifying, we will take volume of hydrogen to the left side of the equation, and 0.5 multiplied by 24, answer will be 12 dm cube. So volume of the hydrogen gas will be 12 dm cube. Example 3. Calculate the volume occupied by 200 gram carbon dioxide at room temperature. In this case, given data is the mass of carbon dioxide. So number of moles are not given at room temperature and pressure, and we have to find the volume. Since number of moles are not given, we will have to find the number of moles first, and after that we will use the formula. The formula which we have already studied is the number of moles is equal to volume over molar mass. And volume, we have to find the volume. Volume will be equal to number of moles multiplied by molar volume. So we will just simplify this. We have rearranged this formula, and we already know that number of moles is equal to mass over molar mass. Mass of carbon dioxide is given here, which is 200 gram, and we will put this formula in the above formula, which is volume is equal to number of moles. Instead of writing number of moles, we will write here mass over molar mass multiplied by molar volume. Mass of carbon dioxide is 200 gram. Molar mass of carbon dioxide is 44 gram, and molar volume is 24 dm cube. After multiplication and division, the answer will be 109 dm cube. First quick check of this chapter 15.1 is calculate the amount of CO2 in 100 dm cube at room temperature and pressure. So in this example, in this problem, amount or number of moles have to calculate, and dm cube, 100 dm cube, that is volume is given, volume of carbon dioxide is given. So its solution is given here. Volume given is 100 dm cube. At room temperature, 1 mole of gas occupies volume 24 dm cube. Formula used will be amount, that is number of moles, is equal to volume over molar volume. Molar volume is 24. So amount of carbon dioxide or number of moles of carbon dioxide is equal to 100 divided by 24, and answer here is 4.17 moles.